is that the list should become empty. So here the result is node does not exist. When it is empty, the result is list is empty. When there is one node, and that there are two possibilities, the node to be deleted is present, the node to be deleted is absent. So in this case, when there is only one node and the node to be deleted is absent, then the outcome is does not exist. So you have to deal with these cases. Okay. And third is uh, there are many nodes. Many nodes means more than one nodes. Okay. So these are the three cases you need to consider when you want to perform deletion of a node in the link. So when there are many nodes, there are again two possibilities. When there are many nodes, node is present and it is absent. So when the node is absent, you have to output the message doesn't exist. You have to output the message doesn't exist, and when it is present, delete node. You have to delete node. So you may note down these things. These are the possibilities. So if you work based on this thing, then your answer, your program will be correct. Okay. Now consider how to check if the list is empty. When head is when head is zero, then list is empty. Then you have to display the message node does not exist. And when there is only one node, how you detect there is only one node? Head. If the list is not empty, then you have to check if it is having only one node. You have to check if it is having only one node. How you check if there is only one node? In one node, this is the first as well as last node. This is the first as well as last node. So previous of this node, it is the itself. Previous is itself, and next is also itself. So there are two pointers. Previous is also pointing to itself. Next is also pointing to itself. So this is a one node doubly circular linked list. This is one node doubly circular linked list. How you detect that there is only one node in the doubly circular linked list? So head is also having address 1000. Previous of the node is also having address 1000, and next of the node is also having address 1000. So if you have to check the condition, if head arrow, if head means star p, so star p arrow previous is equal to star p. If previous arrow star p arrow previous, if this is same as that of star p, then there is only one node. So again in this you have to check the condition if this is the node to be deleted. Okay. So again there is if in this case. So how to check if this is node to be deleted? Suppose this is node to be deleted is num. That data is present in num, and check num with this data. So star p arrow data is equal to num. Star p arrow data is equal to num. Then you have to delete this node. How you are going to delete this node? Make temp to point to this. Oh, okay, sorry. Directly, yeah, make temp to point to this, and make head as null. Make head as null. Head means star p. Make it null. And deallocate the memory. First, store star p in temp. Star p. Store star p in temp, and delete. Okay, then store null in head. Store null in head. store null in head, store null in head, and then deallocate deallocate this node whose address is present in temp. So for that, call free temp. So this is the code to delete the only one node, and that is the node to be deleted. So how we check it is only one node? So previous star p arrow previous is equal to star p. So star p arrow previous is equal to star p. So 1000 and 1000 both are same. Then you have to check whether this is the node to be deleted. Then how you check? Star p arrow data. So star p arrow data is if this data is num. So this data is num, that is node to be deleted. Then make temp to point to this node. Make temp to point to this node, and then make this head as null, and then free temp. Okay. So with this. This we handle this case. If there is only one node and that is the node to be deleted, then make empty. Okay. So if it is not the case, if this is not the case, if this condition is not true, star p arrow data is not equal to num. If star p arrow data, so this head is nothing but star p. If star p arrow data is not equal to null, means this is not the node to be deleted, and there is only one node, means node does not exist. The node to be deleted does not exist. Then in else part, you have to write this message. In this else part, write the message node does not exist. So this is the logic for this I am explaining. So this is the case I have handled right now. Okay. Now next. Now third case. What is the third case? Now third case, it is having many nodes. So this is the example of that. It is having many nodes, and in that the node to be deleted may be present, may be absent. Means you have to find out the node to be deleted. You have to find out the node to be deleted. So the node to be deleted can be the first node. The node to be deleted can be the in-between node, or the node to be deleted can be last node. So you have to deal with the cases appropriately. Okay, so first step is to find out the position. First of all, you have to make the pointer to point to node to be deleted. Okay, so here this is this is a traversing the list in order to find out the node to be deleted. So data is found in the first node. So likewise, then you have to traverse the node, and here actually previous is not required because it is doubly circular linked list. So let us go to the doubly circular linked list. So here is the doubly linked list. Yeah, now this is doubly circular linked list. So in this doubly circular linked list, we are discussing Insert after is over, insert before is there, insert at is there, then deletion of the first node, deletion of the last node. So in the nodes you can refer all this, it is given. So delete at is given, and deletion of the node. So first we have discussed this part. If it is empty, this case we have discussed, then you have to then check if it is the only one node, okay, and then delete that node. Now you have to check whether the given node, if the given node is the first node, okay. If it is not the first node, then check, then locate the node where the node is present using R. So R is used to traverse the node, okay. R is used to traverse the node. So now here we are using R to traverse the node. So make R to point to the first node and check whether this node is the node to be deleted. So that is shown over here. So make R to point to first node. Okay. And then now here the condition is if the node to be deleted is this first node. If the node to be deleted is first node. So you want to delete this. Okay. So how can you delete this? You have to go to the last node. Okay. You have to go to the last node. In last nodes, next part you have to store address of this node. Okay. So that is shown over here. So if temp arrow data is equal to value. So here if temp is pointing to this node, temp is pointing to temp arrow data is the node to be deleted. So using R, you are traversing till last node. So here R is pointing to the last node, and here in last node's next part, you are storing second node's address, and then you want deleting first node. So that is the code given over here. So using do while, it is traversing to the last node. So how you get to the last node? R arrow next not equal to uh, Q. Okay, go on moving to the last node. If it becomes equal to the Q, it it reaches to the last node. Okay, and then delete that first node. Delete this first node. Okay, now if it is not the first node, then it can be in between node. So the else of this part. So else of this part is, and else of this if is it is in between node. So else of this is in between node or last node. Okay, then you have to find out the desired node. So while s arrow next not equal to q means while you have not reached to the last node and the given node is not the node to be deleted, go on moving until you reach to the desired node. Okay, until you reach to the node to be deleted. So s will go on pointing, s will point to the node to be deleted. Suppose the node to be deleted is this 20. So s is pointing to this. Okay, now how you delete this 20? So in the previous node's next part, stored this node's address. So this node's address is present here. So you pick up this address and store it over here. Okay, so this link is established, and then in next node's previous part, store this node's previous address. So establish this link. Okay, so when you want to delete this node, you have to establish this link and you have to establish this link. Okay, so how you establish this link? Store this node's address in this node's next part. And how you establish this link? Store this node's address in previous of this node. Okay, and then free s. So that is done over here. So here next this pointer manipulation is done, and then free this. Then else of this is data doesn't exist. So this is all about how to delete a given node, in how to delete the given node in the doubly circular linked list. Okay. Now, this is all about doubly circular linked list uh, deletion of a given node. Okay, so I have discussed all kinds of linked list, uh, not in all detail, but many of the operations I have discussed so that you can get the idea about how to write this program. Okay, so if time permits, at the time of practical, I will give you singly linked list program, C program of singly linked list, and uh, based on that, you have to develop 6 linked list programs. One is a singly linked list, then doubly linked list, then doubly singly circular linked list, singly linked list, singly circular linked list, then doubly linked list, then doubly circular linked list. So these are the 4 programs, 1, 2, 3, 4 programs based on linked list. So all these are list. Then stack as a linked list, stack as a linked list, and queue as a linked list. So these are the 6 programs you have to develop. Okay, so I will give you the complete program for singly linked list. You have to develop your logic and make sure that you write all 6 programs. Okay, so this is very, very important. You appear for any company interview, or you appear for any very reputed company, so they will test you during the interview, uh, whether you know linked list program, or whether you can able to write the linked list program very confidently. So they will ask you to write stack as a linked list, or queue as a linked list, or doubly circular linked list. They will ask you to write insert after, delete after. There are many, many variations of the linked list. They will ask you to write the code to reverse the linked list. So whatever I have shown you, these are the very basic and bare minimum things that you need to know. So if you appearing for a very good companies, they may ask you very, very difficult program based on the linked list. You're supposed to write the C programming code. So you need to be very, very perfect in pointers, and especially pointer to structure, and how to allocate the memory dynamically. So the student who knows the data structure concept very well, and operations on the data structure, how to write the program to implement the data structure, so he or she may get selected in a very good reputed company, in product based companies especially. So I request all of you to give your maximum time in implementing the linked list program, and don't copy programs. So a lot of programs are available on the internet nowadays. Students are just copying and pasting the programs available on the internet, and then they are submitting. So don't do that. So even you write insert at beginning, or delete at beginning, display. So whenever you're writing this linked list program, start with the singly linked list first, right? When you start with the singly linked list, let me explain you how you need to write the program, so that you can get the confident. Okay, so first write the program insert at beginning. So first declare the structure, then write insert at beginning, ins, insert at beginning, this function, and then only write display function, and call these functions from main. Okay, I call these functions from main. So call these functions from the main, insert at beginning and display. So you get the confidence that your insert at beginning function is working correctly. Okay, and it is actually displaying whatever you insert at beginning, it is displaying. So with this is the linked list program with only 2 functions. Okay, uh, let me develop these 2 functions in front of you, so that you can get confident about this program. So let me develop this aspect in front of you only, so that you can get the confidence. Singly linked list. Now first you need to declare the structure struct. So this notation may be somewhat different than the notation given in the nodes, but try to understand the logic. Struct node, then first part is data, then next is the pointer to struct node star next. It is a pointer to next node, and yeah, now you have to declare pointer to first node. So actually you declare it in main. Okay, struct node and star head. This is the pointer to first node star head, and make it null because initially it is empty. Initially list is empty. So here actually linked list is created, right? Now you write insert at beginning. So it is not returning anything. Insert at beginning. Okay, and then you are passing two parameters. First one is, as I stated, is P. P holds the address of head. So here it is. Struct node star P, and another one is the node, the content of the node that you want to insert. So that is num. Okay, so this is num. Now here, first you have to allocate the new node. So struct node, then star. So let me see what is. This is the first simple program I am writing here. So this is the linked list program. The first is this is the code to display is empty search. Yeah, this is insert at beginning. So this code I am going to write it. So struct node arrow data temp arrow next, and this is temp, right? So okay, now you have to call display function. So display function is written over here. You have to call the display function. You have to write display function void display. Okay, here write struct node, because I have not used this is a simple structure I have declared. I have not used type def. So here type def is used. That's why. So here you can see type def is used. So here type def is used. That's why they are not using struct. Okay. So that's why they are directly using node, right? They have created a type def for node. So that's why they are directly using node. But I have not created the type def. So that's why I'm directly using struct node. It is very simple to understand. Okay. And now display struct node and print. You have to write printf instead of print. You have to write printf, and here you have to write here person D, person D, next. So you have to display data in the node and make the pointer to point to next node, right? So this is the code to display. Now from main, you have to call out first insert the node at beginning. Insert at beginning. So how you call here? They have called insert at beginning like this. So head 5. So this is how it is called, insert at beginning, head, and then my data is suppose 10. So this 10 will get inserted at beginning. Then again insert one more node at beginning. This is 20. Again insert the node at beginning. It is 30. Now call display function that will display the node. Display, and then to display simply pass here write struct node, and to display simply pass head. So here in display simply pass head. So here it is shown display. Here it is single pointer, simply pass head. So again, so it will insert three nodes 10, 20, 30. So how it looks like, see here. So first insert at beginning 10. So 10 will get inserted here at beginning node. Then insert at beginning 20. So 20 you want to insert at beginning. So 20 will get inserted before 10. So head will point to 20, and this 20 will point to 10. Right? So it will look like this. So 20 is inserted at beginning. Okay, now again 30 is inserted at beginning. 30 is inserted at beginning. So I am explaining this part. So first 10 is inserted at beginning, then 20 is inserted at beginning, then 30 is inserted at beginning. So 30 gets inserted at beginning. So how it gets inserted at beginning? First this will point to this, and then head is pointing to this. Okay. Now 30 is at the beginning. So when you display the node, so first display will start displaying from this node. So first it will display 30, then it will display 20, then it will display 10. So output will be 30, 20, and 10. So it will start displaying from first node. So here I have called display. So let me run the program. So here you can make use of struct. Here also struct node. So here Q, so sorry, here it is Q, not P, Q, it is Q. So now it is executed. Now you can see 30, 20, and 10. So this is the output. Okay. So in this way you go on adding. So this is the very simple program. First I added struct node, then I added insert at beginning, then I added display, and then I added main. So in main I called insert at beginning by calling it 3 times. When you call insert at beginning, it will insert one node. So I want to insert 3 nodes. So I will call insert at beginning 3 times, and then I will call display, because I want to test whether all these 3 nodes are inserted. So when I run this program, I can see all these 3 nodes are inserted. So output is 30, 20, and 10. Okay. Now similarly, you can steadily go on adding other functions also in this program. So display is already there. Then you can add count. So it will count how many number of nodes are there in this. So that gives you more confident count. So void, it doesn't, it will display the count here only. So struct node, struct node, and printf, and this is %d. So number of nodes in linked list are, number of nodes in linked list are /n, right? So these are the changes I have done. Okay, so now I will be calling this count function. Call the count function by passing head. Count pass head. Right? Now you can see how many nodes are present. PTR is equal to PTR arrow next. PTR is equal to PTR arrow next. Yeah, now you can see it is showing 3 nodes, 30, 20, 10. Number of nodes in the linked list are 3, right? So this is how you can add a count function and call the count function here. Now the next function that you can add is empty. You can add and call it. Then search node. Then you can search whether the given node is present in the list. Okay, so whether it is found or not, you can copy this and you can call this search function. So I'm calling this search function. So you have to call search function here. So struct node, wherever there is node, make it struct node. Printf node not found, node is found at. So it will show at what location node is present, position. You have to write struct node. Yeah. Now you have to call search function. You want to search function. So search function is search search. Then here it is showing me hint. So to that pass head and what node you want to find out. I want to find 20, whether 20 is present, because I know that 20 is there and I'm searching for node 20. So here search for the presence of the node 20. So you run this. So here it shows first 30, 20, 10. These are the 3 nodes. Number of nodes in the linked list are 3. Node is found at position 2. So 20 is node to be found. So 20 is present at second position. At first position, 30 is there. At second position, 20 is there. So it is showing second position. So this is how you have to work out with search. Okay. Now again, you can add insert at end. Insert at end. let me add insert at end. So first you add this part. So go on adding this in this way so that you can get the confident. Insert at end. So I'm writing this void. Insert at end. So wherever there is a node, make it struct node. Temp arrow data. Temp arrow data is equal to num. Temp arrow data is equal to num. Temp arrow next is equal to null. Temp arrow next is equal to null. Temp arrow next is set to null. Okay, so this is first part till here. So next part, else part, you can copy paste this else part. So this is the if part, this is the else part. So R arrow next. R arrow next. This is also R arrow next. So here struct node. Here also make struct node. Your temp arrow data. See, I'm purposefully writing the program in front of you so that you can get the confidence how to convert the given program, how to convert the algorithm into the program. Next. So this is insert at end. Okay. So now I want to call insert at end. Insert at end. So first I inserted 3 nodes 10, 20, 30 at beginning. Then I displayed, then I count, then I search, then I call insert at end. Let me call insert at the end. Insert at end. Okay. Insert at end. I want to call. You have to pass address of head as it is required, and I want to insert at end 50. Okay. And again, I want to display an account. Display means again I want to display how many nodes are there, and again I want to count, and then I want to search whether 50 is present. So see what I have what I have done in the main. In main, I have inserted 3 nodes 10, 20, 30 at the beginning. So first 10 will get inserted at the beginning, then 20 at the beginning, then 30 at the beginning. Then all these 3 nodes are displayed 30, 20, and 10. Then it will count how many nodes are there at that time. So it will show three nodes because only 3 nodes are there, 10, 20, and 30 here in this count. The output will be 3. Then you are searching at what position 20 is there. So 20 is there at second position, it will display second. Then you are inserting at the end 50. So where 50 will get inserted after 10 because 30 is at the beginning. So the output will be 30, 20, 10, 50, and then count is 4 nodes and search where at what location 50 is present. So let me run this program. This is temp arrow next. So this is semicolon. Make sure you write the semicolon at appropriate location. Now you can see the output. First is first 10 at the beginning, then 20 at the beginning, and then 30 at the beginning. So it will be 30, 20, 10. Then number of nodes in the linked list are 33 here after this, and number 20 is found at location 2. Then we inserted 50. After inserted 50, we displayed it. So 50 is inserted at end. You can see after 10, 50 is inserted. The number of nodes in the linked list are 4. Here there were 3. Here now after inserting 50, the number of nodes are 4, and you are searching for 50. So 50 is present at location 4 at fourth location. So 1, 2, 3, 4. So this is how you go on adding these functions in the C program and develop your C program. So I hope all of you have got this thing, and I will share this program. I will make this program available to you right now on the team, so that you can make use of it. Sample linked list program. Let me make it available as a .txt .c file. Here, save as sample singly linked list .c. Sample singly linked list .c. So let me write in front of you on